there's that. Still waiting for the rest to come back from lunch. They'll get here eventually. I hope. Hey, there's one. Leo, we can hear you. And Andre, good. Is that all? All right, then. Good afternoon, everyone. Welcome back to geometry. We have more problem solving in store for you today. I know the first one was so much fun. You're like, Mr. Apple, how can we possibly top problem set 1? Well, problem set 2 is, I was about to say twice as good because it's number 2 instead of 1, but I don't think that's quite true. 50% better, maybe? Anyways, before we start the new problems, though, we want to make sure we've got our maximum learning out of the old problems. So here then are the answers to problem set 1. Please, please, please have that out and be checking and comparing your work. I check your homework in, I look through it, but I do not check for correctness and count that as far as points. So it is on you to look back and see, okay, how did I do? Did I get this one correct? Not correct. If you didn't get them correct, feel free to ask. Have me explain. Stop me. Wait, Mr. Apple, can you explain that one a little more? I still don't get it. Okay, anytime. All right. Oh, who just popped in? Angel? Okay, thank you. Update that. So here we go. Number 1, how many equilateral triangles of all sizes were there? You could make 13 different triangles in here. Remember, you got to get the 3, the 2s, and the 1s, and don't forget the guys that are upside down. Okay? 13 total triangles there. Tetrominoes. Tetrominoes, 4 square shapes. There are 5 totally unique tetrominoes. If you're basing this off of your Tetris experience, know that Tetris has the flipped versions. Okay? Flipping them does not make them unique. So we take the L and the J from Tetris, that's the same thing. The S and the Z from Tetris count as the same one. So there's only 5 totally unique shapes. And next up, coloring in 6 of 9 squares so that you get no horizontal, vertical, or diagonal connections, no bingo. This is like the anti-bingo card. Wait, no, bingo would be 5 by 5. Tic-tac-toe, okay, no tic-tac-toe 3 in a row, right? You actually have to make the empty spaces line up diagonally there. And so then that blocks every row and column, and then you can't get the other main diagonal either. However, for a 4 by 4, it's quite different, see, because I can't put the 4 empties in a diagonal because of the even number. There's no middle square that counts as both diagonals. So if I made these 2 the blank ones, these would be filled in, and now it would have this diagonal there. But otherwise, we still get a very similar looking shape, right? You've got this kind of L pattern. This has a little L shape here. This is actually it showed up directly in that milk crate problem as well. Something to keep in mind. Okay, any questions on those problems so far? That was all the level 1s. No? Well, then let's go on, take a look at the level 2s for those of you that completed. Here are the pentominos. All 12 unique pentominos. Okay, so I've Went ahead and I actually drew them out for you so you can see the orientations. And people have done different mathematical things with these. They've given them all names. Letters, you can turn it sideways, and this is an X, and this is the W, I think, wait, 1, 2, 3, 4, 5, 6, oops. There we go, Pentomino. I had one too many squares there. I got carried away with the stair steps. So there you go. And for the next step, can you fit them together into a square? Yes, you can. There's actually lots of different ways you can combine these together to make a 5 by 5 square. It's a really neat kind of problem to play with. So here is one example. I'm sure you could look up many more online. And then to fit 3 of them into a 3 by 5 rectangle, here again is only one possibility. There's other ways of doing this. I couldn't fit them all on the same page. But there you go, it can be done. And then finally, for anyone that attempted the level 3 question, they got to see the hexamino. Hexamino is now 6 squares connected together. And the beautiful thing about 6 squares together is you could now fold this shape up to make a perfect cube, which is pretty cool, which means all of the hexaminos are actually nets of a cube. And so this question then relies a little more on your visual spatial reasoning skills, the ability to visualize, if I folded this up, how would it become 3-dimensional here? And so I've kind of sketched there what would happen with C here. If I took this one face and had that facing me, that would be the front. This 3 panel, imagine that folding around to the side there. And then the 2 folds down from there to form the top. The 4 folds up and in to get onto the bottom there. And then the 5, right, the 4 now is on the bottom. The 5 goes up from there to form the back, and the 6 wraps around to form that last side. Okay. If you don't believe me, go ahead. Draw one out nice and big, cut it out on paper, put them in, and then fold it up yourself and see how that works. That's the one thing we can't do here with the digital medium is present 3D objects very well, because you still only have the 2D picture on your computer screen. All right. Any final call for questions on problem set 1? Okay, hearing none, then let's take a look at problem set 2. There is more to do, even from the same section of the book. I mentioned in one class, right, there was just too many good problems to fit in only one assignment, so we're doing 2 of them. Here we have another classic toothpick problem. This one starts out with this 2 by 3 squares arrangement, and we want to remove exactly 6 toothpicks and leave 2 squares. Okay? There should be no leftover toothpicks. What they mean by leftovers is you should not end up with like, oh, here's a square and one sticking out. Funny there. Every toothpick left on the board needs to be a side of a full square or part of a full square. Okay? Only completed squares will count. So that one, you remove 6 toothpicks to get 2 squares. Part B, remove 5 toothpicks to leave 3 squares. So we move 1 less, but we get a whole extra square. Oh, that's interesting. See, you're gonna have to do something really different because 1 extra toothpick does not a full square make. So there's gonna require some interesting thought here. If you have some actual toothpicks, okay, pick up a box, play with them, manipulate them around on the table. It is way faster and easier that way, and you can visualize it than trying to draw and erase and redraw everything. So I would recommend that. They're cheap. Stop by the dollar store, pick up a box. They'll come in handy, all right? Next up, we have a classic, can you draw it without lifting your pencil kind of question, okay? This is a great little puzzler to share with your friends and say, hey, bet you $2 you can't do this, or $5 if you're feeling really bold, right? There's some money on the line. Go for it. Can you retrace this without retracing any lines or lifting the pencil? If so, describe how. If not, why not? Any problem that says if not, why not, you have to have a good reason. Okay? You can't just say, nope, I wasn't able to find how to do it, therefore it must be impossible. You have to have a specific reason. You have to be able to point to somewhere in the problem and say, here, right there, this piece of information, this fact, or this aspect, I don't know, is it the like intersection at the middle? Is it the corner? Is it the fact that it has 4 corners? If this was just a triangle, it could be done, but right, you have to something specific, point to and say, this is causing problems, here's why. I can't do it. If you are able to figure it out, then please, please, please don't just draw this shape and be like, oh yeah, I did that without lifting the pencil. I have no idea how you drew it. So give us a diagram, put a big old dot where you started, and as you draw each line, put a little arrow there to indicate the direction you've gone, so I know which way this is traced, and number them, especially if you come back. Like we could return, what if this line comes back here? Right, this way, so 3, there's 4, and then I go back from there, 5, right? I need to know which direction you took at this, at this intersection first. Did you go this way? Did you go that way? Okay, so number and give directions so we can actually see exactly how you traced it out. All right, and then number 3, well, number 27, the third level 1 problem for you today involves a set of blocks. We have 10 blocks with heights of 1 centimeter, 2 centimeter, 3, 4, 5, 6, 7, 8, 9, 10. Right? All the heights are accounted for. The child wants to use only these 10 blocks, and I should kind of add to that, and all the 10 blocks, to build 2 separate towers that are exactly the same height. Can it be done? Again, if so, give us a clear picture how. If not, explain what causes the problem. Don't just say, well, I tried a bunch of ways and none of them worked. How do we know you tried all the ways? Okay? Unless that is your explanation for how. It's like, no, I very systematically set up, here's every possible combination, you can see none of them work. That is proof by exhaustion. That's acceptable. But just to give you an idea, here is a 1 centimeter block, plus the 2 centimeter block is a 3 centimeter tower, and you can use just those single 3 centimeter block to make another 3 centimeter tower. So that's what we're dealing with here, right? 2 towers, same height, but this is not a acceptable answer because you still have 7 extra blocks. You got to use only these blocks, but also all of the blocks. They should have specified that in there. Otherwise, I'd be done. Be like, oh, we'll just make them short. We want taller towers. All right. Any initial questions or confusions on those problems? What's expected from them? No, my hope is that this quick preview kind of sets up step 1. You now have an understanding of each problem, what it's asking, what it's providing. And you can just begin with step 2. Pick out a strategy from here. Okay, that's it. The rest of class is to start the homework. This problem set is due Friday morning. You've got these 3 level 1 problems here. There's also the level 2 and level 3 problems. I have not talked about those. I'll leave those open to you. But if you finish the level 1s, go on and give those upper level 1s a shot. But for now, I'm going to leave you the rest of the class period to work. Let me know if you have any questions. I'm happy to help you out on any or all of these.